All right, hope everybody's having a good day here today. I'm going to just kind of finish up the factoring. Everybody should have submitted the worksheet from yesterday. Here's just the answer key. Go ahead and I'll scroll through it, check your work, pause it as you need. But all problems factor at least once. All right, and then there's through 20. Now 20 just has a GCF. And then this second part does not factor again because it is a sum of squares. All right, I know in a couple classes I didn't get all the way done. I'm going to run through a couple of those examples at the end just so that you see them. And then I'll kind of start with today's work. All right, sum and difference of squares. I know I got to this in some classes, but not all of them, or partial problems. So if you already have a couple of these down, fine, but I just want to go through the other ones. If you have 4x squared minus 25, you have two terms. That's what you're looking for. That's the difference between that and the trinomials. We want them to both, and there's no GCF. We're looking for what multiplies together by itself to get the first term. So it's 2x times 2x, and then what can square together to get 25. It's negative 5 and positive 5. If you FOIL those back together, the two middle terms add up to 0. You end up with just 4x squared minus 25. This second one here, 18x to the fourth minus 8x squared. First rule is always factor out of GCF. At this point, you could not factor this problem because it does not have, they're not a square of another term. So we take out the GCF, which would be 2x squared, and we divide each by 2x squared. I get 9x squared minus 4. Well, 9x squared minus 4 is a difference of squares. This is 3x times 3x. This is going to be minus 2 times positive 2. So that will factor again. And so I get 2x squared times 3x minus 2 times 3x plus 2. Now I can't do anything else with that one. That one will be my final answer. Oh, hold on. Third one here. And I talked to a lot of you about this one. This one does not factor. If you have a sum, it will not factor with the two terms. Most people will say, what about x plus 5 times x plus 5? Well, if you FOIL that together, you'll get x squared plus 10x plus 25, which is not equivalent to the original one. Then some people will say, what about x minus 5 times x minus 5? Well, if you FOIL that together, you get x squared minus 10x plus 25. So both of those will give you a middle term. And then every now and then I'll get x minus 5 times x plus 5. Well, if you do that, you do get x squared. You get plus 5x minus 5x. But negative 5 times positive 5 is minus 25. And so you get a minus instead of plus. You cannot multiply two binomials or two of anything together to get x squared plus 25. Does not factor, and then sometimes you will see if something doesn't factor, they'll put the word prime down. So you got to be careful of that. X to the fourth minus 16. All right, well, this is a difference of squares. To get x to the fourth, it is going to be x squared times x squared. And then to get minus 16, it's going to be negative 4 times positive 4. Now, you always have to double check, since we're using the term factor completely. X squared minus 4 factors again. That is another difference of squares, where it's going to be x minus 2 times x plus 2. X squared plus 4 is similar to number 3 up there. It has a plus in between them. It will not factor. This will be the final factored form for x to the fourth minus 16. That is completely factored. Equivalent, everything's a product, and everything has been simplified. So I just wanted to hit sum and difference of squares again, okay, for that. And now we're going to kind of move into today's lesson. And let me see something. Okay, again, here's your answers. I think everybody, hopefully you've already gone through them. You'll see where you have some difference of squares. And then if you do have any questions, hold on to those. I'll help you out on Friday. All right, yesterday we did any trinomials. I said do guess and check. And I know some of you do them a different way, using what I call the grouping method. And I just wanted you to go through to kind of have a better understanding of kind of what's going on with factoring. You can use the grouping method to solve or to factor trinomials. And so let's just review that. Some people call it like the key number method. It has a couple of different names. And I know Mr. Laverick and Mrs. Napoltz and Mr. Hudson all teach it as well. And I teach it too. I always want you to be able to do it by guess and check as well. All right, grouping method. This is what you would do. You would take the first constant, first coefficient times the last. So you take 2 times -6, which is -12. And then we try to figure out, and I just use P and Q for whatever reason. I need two numbers that multiply to get -12 and at the same time add to get whatever the middle term is, which is 1. Well, those two numbers are going to be -3 and 4. If you can figure out those two numbers, you know it factors. Now what we do is we split up the middle term. And now we split it up into 2x squared. I like to put the negative first. It really doesn't matter if I got a negative and a positive. 2x squared minus 3x plus 4x minus 6. If you do, this should just be 3x. If you do switch the order, your work will be a little bit different, but you got to get the same answer. All right, we group like we did yesterday. We find the GCF. Well, the GCF of this one is just an x. So I factor this one on its own, and I get x times 2x minus 3. Plus, this one has a GCF of 2. So I take that and I divide that into 4x minus 3, and I get 4x minus 6. And I get 2x minus 3. I got the same group. So that goes out in front, and then when I factor that out, it basically leaves me the x plus 2 in my other group. That right there is going to be my answer. I know many of you like this because it gives you a distinct set of steps to follow. And I don't blame you. I do want you to be able to try and guess and check, especially when your first number and your last number are primes. You don't have a lot of options, and I think it just gives you a better understanding. But I am not going to mandate one way or the other. Grouping method again. So you got this. You're going to take 3 times 8, which is 24. What multiplies to equal 24 and at the same time add to get 14? Well, they both have to be positive. I said 14 and I wrote 12. They both have to be positive. Your two numbers are going to be 12 and 2. And so we write this as, now we break up the 14x into 3x squared plus 12x plus 2x plus 8. And then I factor each individually, and I take out a 3x, and I get x plus 4. I divide by 2, and I get x plus 4. And so I got the same group. And so in the end, I get x plus 4 times 3x plus 2. Just like yesterday, it doesn't matter what order you put those in. Now I'm just going to do one more of these two here, okay, using the grouping method. Let's take a look here. Let's do number 3 because they both of them have to be negative. So you have to take 6 times 3, which is 18. I want two numbers that multiply to equal positive 18, but add to equal negative 11. Only way that can happen is if they're both negative. So negative 9 and negative 2. So now I'm going to split this up into 6x squared minus 9x minus 2x plus 3. When you factor by grouping here, okay, the common term in here is 6x squared minus 9x. It's going to be a 3x. And so when I divide by 3x, I get 2x minus 3. All right, if you look at the second one here, you don't have anything in common between 2x and 3. This is the one case where we're going to use 1 as our GCF. When we're doing this grouping and they don't have anything in common, I'm going to use a 1. You always want to have whatever the sign is between those is the sign of the GCF. So I need to make this a negative 1 as my GCF. And I write that down here as minus 1. And I divide both of those by negative 1. Well, negative 2 divided by negative 1 is positive 2x. 3 divided by negative 1 is minus 3. Okay, so now as long as I have this, now using that negative 1 allows my two groups to match up. So now I got 2x minus 3. I got 3x minus 1. Okay, so 2x minus 3 times 3x minus 1. If I FOIL, okay, I check the outer, it gives me negative 2x. I check the inner, it gives me negative 9x. That gives me negative 11x. Okay. All right, now I'm just going to do guess and check on this last one. If you want to do grouping or whatever, I'm going to go ahead. Now, here's the issue. That's 4x squared. My first inclination would be 2x and 2x. But here I'm going to run into a problem because I get negative 12. I know one of them has to be a negative and one has to be a positive, but here I got every one has an even number in here. So if I use any even number, so like 2x plus 3 and 2x minus 4, I'm always going to have what we talked about yesterday. I'm always going to have a common factor. These do not have anything in common, so I know it'll automatically be wrong. And so no matter how I rearrange to get 12, I'm going to have a 2 and a 2. I'm going to get a common factor. So I know this will never work. So I'm just going to use now 4x and x. And one of them has to be positive, one of them has to be negative. And so when I'm done multiplying, I got to get 12. 2 and 6 won't work either because I still have this 4 here. So it's got to be 3 and 4 or 1 and 12. Okay. And now let's take a look at what the possibilities could be between 1 and 12 and 3 and 4. So if I make this a minus 4 and I make this a plus 3, okay, it satisfies the 4x squared because 4x times x is 4x squared. It satisfies the negative 12 because 3 times negative 4 is negative 12. I just got to check to see if my two multiplications here will add up to negative 13, and they do. So right there, that lets me know that is correct. So trinomials, you got two ways, kind of guess and check, and then we got what I refer to as the grouping method. You might call it the key number, different names it has. I'm not going to mandate one or the other. I do want you to be familiar with guess and check. Okay, I think as you move higher up in math, that's important. You can be able to do things and I think you have a deeper understanding when you do that. I do use the grouping method when I know I have non-prime numbers in the front and the last number, and I know it's going to be a difficult guess and check. I will do that. Okay. All right, a couple things. Others like kind of special cases called perfect square trinomials. Perfect square trinomials are called this when the first and the last term are a perfect square. Now, we talked about it a little bit yesterday, but just a quick recall. Perfect squares are numbers such as 1, 4, 9, 16, 25, 36. Any number whose square root is a whole number, or you can square a number to get that. So 5 squared is 25, 6 squared is 36. You can do this just like we did any trinomial. You can do guess and check. You can do the grouping method. They will work. But if you notice the first term is a perfect square and the last term is a perfect square, I would encourage you just to test plugging in the squares that multiply to get 4x squared would be 2x, and then to get 25, it would be a positive 5 and a positive 5. And then just test it either mentally or multiplying it out. But these two numbers here got to multiply when you're and add to get the 20x, and they do. So this one is 2x plus 5 quantity squared. Okay, I usually don't mind if you keep it as 2x plus 5 times 2x plus 5, but a lot of times in the book or in standardized tests, they'll write it as 2x plus 5 squared. Okay, factor 36x squared minus 12x plus 1. This is a good old-fashioned trinomial. I can use any of my methods, the grouping method. I can use it, basically guess and check will be a little bit what we're doing here. But I notice perfect square, 6x times 6x will give me 36x squared. I notice perfect square. Well, 1 times 1 will give you 1. Don't forget about that one. Some people do. So I'm automatically going to check. I don't want a 3 there. Off the bat, I'm going to put a 6x here. I'm going to put a 6x here. Now, you got to watch your signs. These do multiply to get 1, but since that's in the middle of the negative, they both have to be negative. 6x minus 1, 6x minus 1. When I FOIL, I do get minus 12x in the middle. So you can write that as 6x minus 1 quantity squared. So perfect square trinomial, look at the first and look at the last. Now you get a second variable. Well, it's still a perfect square. 16x squared is 4x times 4x. 9y squared is 3y times 3y. I didn't get to a problem with 2 letters in all classes yesterday, but hopefully you saw that on the homework, kind of how you handle that. That means that that second term right here is going to have that second variable. So I'm going to try this, and it does not guarantee it will be right. You have to check it. So I'm going to put 4x and 4x here. Since that's a minus in the middle, these both need to be negative. 2 negatives multiply to get a positive. They'll add to get a negative. If I do test the outer and the inner, that gives me negative 12xy minus 12xy, which does add up to negative 24xy squared. And so 4x minus 3y quantity squared will be the factored form. Now, when you have these, sometimes they get a little difficult because if you multiply doing the grouping method, it's 16 times 9. It's going to give you a big number. Okay, they're not always as easy as some of the other trinomials. But if you notice you got a perfect square front and back, it makes it a little bit easier. All right, so that's perfect square trinomials. Sum and difference of cubes. Special cases here. If you have something of the form a cubed minus b cubed, it can be factored into the following case. A minus b times a squared plus ab plus b squared. That's a difference of cubes. A sum of cubes can be factored, whereas a sum of squares, which we talked about yesterday and a little bit today, cannot. It factors into a plus b times a squared minus ab plus b squared. These are extremely similar. One thing to help you remember which form to use is an acronym called SOAP. This helps with the signs. You do need to know these equations for the quiz and for the test. Okay, I guess memorize if you want to word it that way, but you need to know them. Okay, starting with your original term. If this is a minus in the middle, on the answer, your first sign is going to be the same as the original one. So since this was a minus, this is going to be a minus. Since this is a plus, this will be a plus. The second sign will be the opposite sign of the original. Since there's a minus, that's going to be a plus. Since there's a plus, it's going to be a minus. Now, the last sign is always positive. Okay, so it doesn't matter. So that kind of helps you keep it, because everything else is, in terms of like the variables and the powers, is the same, exactly the same, except for the signs. So SOAP, same as the original, opposite of the original, always positive. Now we're looking for things in terms of cubes instead of squares. It could be constants, or it could be variables. X cubed is cubed. 27, you might look at it and say, well, that doesn't fit, but 27 is the same as 3 to the third power. So I can rewrite this as x cubed plus 3 to the third. What that means now is basically my a is going to be x, my b is going to be 3, and I'm going to plug it into, since it's a plus, this formula here. All right, now to help learn, it's always helpful to rewrite things. Every time you write it down, it helps it to sink in. So even though I got it right in front of me, I'm still going to write it down. And then everywhere there is an A, I'm going to replace it with an X. And then everywhere there's a B, I'm going to replace it with a 3. Now, when you get to squareds, okay, that's going to be x squared minus A, which is x, times 3 plus b squared. Now, here's one thing I want you to do: simplify it to its nicest form before you're done. Don't leave it like this. For first of all, you got this x times 3. We never write anything that way. That's going to be minus 3x. And then 3 squared is plus 9. In this case here, if you can jump from the first to the last step, that's absolutely fine. But here's what we're saying. X cubed plus 27 is equal to this factored form. It's a product of a binomial times a trinomial. If I would multiply them together, I would get back the original one. I don't want to take the time to do it here, okay, while you're watching this. So that's x cubed plus 27. You always look for difference of squares first. If it's something the difference of squares, because there's a rare case where it could fall under both categories, use the difference of squares. This is not a square because that's cubed. Can't get around that fact. So now you say, all right, can I write this as something cubed? Yes, it is 4y to the third power. 4 cubed is 64. Y cubed is y cubed minus 1 to the third power. So now this will fall under the a cubed minus b cubed category. Well, a cubed minus b cubed is a minus b, same sign, a squared plus ab, opposite, and then always positive, plus b squared. Here we're going to let a equal 4y, b is just equal to 1. So a minus b becomes 4y minus 1. These signs will not change. You always use, like if it's a minus, do not put minus 1 in parentheses cubed. It's just the 1. A squared, now this is where I do see mistakes. That is 4y, I'm going to take 2 steps here. To the second power, you got to put it in parentheses. Plus 4y times 1 plus 1 squared. Now I'm going to simplify it. And I get 4y minus 1. 4y squared. That has to be 16y squared plus 4y plus 1. That is going to be equivalent to 64y cubed minus 1. And then you can multiply it. You could multiply it out to check. All right, this one gets a little bit, I guess, more complicated. It might not be as obvious as the other two. That is a difference of cubes, sorry. Cannot be squares because of the x cubed. Now, what cubed gives me 8x to the third power? 2x to the third power does. Plus, what cubed gives me 125y to the 6th? It will be 5y squared to the third power. This is now the form a cubed plus b cubed, which we know factors into a plus b times a squared minus ab plus b squared. Everywhere I see an a, I got to put in a 2x. Everywhere I see a b, I got to put in a 5y squared. So this first one is just pretty straightforward. 2x plus 5y squared. I'm going to do this in 2 steps. A squared, since a is more than just a single constant or a single variable, put it in parentheses. 2x squared minus a is 2x. B is 5y squared plus, and since I have a 2-part 5y squared to the second power. Simplifying this, first one will not be affected. 2x plus 5y squared. All right, 2x quantity squared. Make sure you write that as 4x squared. Multiply those together. Do not leave that. That is poor format. Minus 10xy squared. And then this will give me plus 25y to the 4th power. Okay, 25y to the 4th. Okay, so there is our factored form. Okay, for that perfect, or for that difference of, or sum of cubes. So you got those 2 forms, and you do need to know those. All right, let's just clean a couple things up here. Factor each polynomial completely. And essentially every direction should say completely from here on out, and I expect you to factor completely. I don't expect you to stop and if something factors again. Trinomial, you can do guess and check. You can do the grouping method. Now, the grouping method, here's where I do like it, and I like it a lot. Because if you do the grouping method here, 2 times negative 8 is negative 16. So now I need 2 numbers that multiply together to equal negative 16, and they add to get 7. All right, take a second. I'm going to take a second, see if you can come up with those 2 numbers. You can't. I don't care how you try. Give me 2 numbers, because multiply to get negative 16. You got 1 and negative 16. You got 2 and negative 8. Or you can put the negative, but it doesn't matter. It will not add to 7. So if you're trying to do the grouping method and you cannot come up with the numbers that multiply to get the negative 16 and add to 7, that means it is not factorable. So if you were doing the guess and check method, you could spend some time and you wouldn't maybe be sure. Sometimes, like I said, this can be called prime. So not factorable or prime. Factor 2x to the 4th minus 9x squared plus 4. All right, this is just a trinomial. I wanted to give you this because I don't want you to think that everything's going to be in term of x squared. Okay, this will work because I'm going to put 2x squared in my first group. And since these are relatively small numbers, I'm going to do guess and check. I'm going to put x squared in my, as long as these two are the same, when I do FOIL, it's going to give me x squared in the middle. So 2x squared times x squared will give me 2x to the fourth. To get the 4, I can do 4 and 1 or 2 and 2. Well, it can't be 2 and 2 because that will give me a GCF between those two. So I'm going to try 4 and 1, and both ones have to be negative. Uh-oh. All right, it's not writing for some reason. Let me try something real quick. We'll clone this page. And I'm still not getting anything. All right, I'm going to pause, see if I can fix it, and then I'll be right back. So let me see. Come here. Okay, I'm going to hit. All right, I'm back. I didn't really figure out why it stopped, and so I'll just continue at this point. I think we had done a little bit of this problem. X to the fourth is still a factorable trinomial. I'm making this 2x squared. I'm making this x squared. 2x squared times x squared is 2x to the fourth. To get the 4, these both need to be negative. And I don't know why that is way over there. And I think I said earlier that the 2 and the 2 will not work, so it's got to be a 4 and a 1. So if I make this a minus 4 and a minus 1, that will give me the positive 4. And then when you do the outer and the inner, you get negative 8x squared minus 1x squared, which is minus 9x squared. Well, part of our rules is factoring completely. Always double check, will it factor further? This first one will not. This second one will, because it is a difference of squares. So this becomes 2x squared minus 1, times x minus 2 times x plus 2. Order doesn't really matter. You could have the x minus 2, x plus 2 first, 2x squared minus 1 last. Does not matter. All right, we got one more to do, and this can be a difficult one because basically just, unless you've seen it before, you really, it's hard to know how to attack it. It's 4 terms. You look for a GCF. GCF is not, there's not a GCF. Your next kind of mental check should be grouping. If you group them as they are, okay, this will not work, and let me show you why, but it gives you the appearance it will. These first 2 terms and these last 2 terms, you will factor some. These first 2 terms are a difference of squares. You get x minus 3a times x plus 3a. Plus, you can factor a 3 out of there, and it gives you 2x plus 3. But at that point, you're done. And you cannot consider this factored because you really have that's one term plus a second term. This is not connected by multiplication. It is not a product. Okay, it is the sum of 2 products. So we cannot consider this factored. You cannot cancel here. This is one where you have to reassemble the terms. And to reassemble, this is what we want to do in this case. X squared plus 6x plus 9. I'm going to put all the positives together, and I got minus 9a squared. Put that on the end. Hopefully you can hear, well, you might be able to hear my dogs going at it a little bit. We're going to group the first 3 and kind of leave that on its own, because x squared plus 6x plus 9 will factor into x plus 3 times x plus 3 minus 9a squared. That we can write as x plus 3 quantity squared minus 9a squared. This is a difference of squares. It's of the form a squared minus b squared. My a is the quantity x plus 3. My b is I'm going to write it as 3a squared. So I'm going to factor it into a minus b, a plus b. So it's going to be x plus 3 minus 3a, and you don't necessarily need the parentheses there, times x plus 3 plus 3a. Now I'm just going to clean this up a little bit because these parentheses are just a little bit of an overkill. They're not affecting anything. So you can write this as x plus 3 minus 3a. And then you can write this as x plus 3 plus 3a. You could keep the parentheses, not an issue, but you could simplify it to this. This tends to be a difficult one because you really haven't seen this format a lot. You do have to rearrange. You cannot factor it in terms of this. So a lot of times your initial reaction is, oh, it can't factor. Not true. Okay, this one will factor. Okay, that's it for today. Here's the assignment. This is out of your book. All even problems, 76, 82, 84, and then 90 through 94 through 124 even. I will collect and grade this. I will grade, I don't know how many problems, 5 or 6, right around there. I will collect and grade this. Okay, so you do not need to upload. I'm not going to have you upload it. I'm going to collect the paper copy. Okay, it's just sometimes easier for me to do that. And it will be due Friday. All right, hope everyone has a great day, and I will see you later.